Hello and welcome back to the channel. It's Mark from PowerSonic and Apprentice 121. Today I am doing a solar PV survey. This is a reasonably interesting one because we're proposing a system on a triple garage and it's going to export its generation back to the house. We've got some existing cables down here. We're going to have a look if we can make use of them. And I'm going to run through some of the things that we need to be gathering in terms of information on a proposal to then fill in a G99 and also ensure that we are proposing the best system for the customer. So let's get on with it and take a look at how we approach that. So first up is to start with the basics and see what you've actually got down in the location you're intending to site your inverter. And you can see here we have got a 10mm 3-core cable coming down to this board. There is good capacity on there. That the consumption down here is tiny. It's basically CCTV cameras and some lighting. And if we're going to put batteries in with the hybrid inverter, they can be run off the EPS port on that inverter, and there is the potential to make use of this to feed our PV system and avoid digging up somebody's rather nice garden leading back to their house when we can make use of something that's already there. There are some issues with this cable, so you need to look at that. It's not been glanded the best way. This board's going to need a bit of attention, but that's by the by in the grand scheme of things. So we've got that in our favour. The other thing you need to do is measure stuff. So we're going to measure the size of this. So this is a triple garage, as you can see on the front there. I can use this and maybe make reference off the CCTV camera to get a length, and then obviously we need a depth as well. So that's going to give us our footprint of the building. I know the solar design software will do an aerial shot and do lots of this anyway. However, taking actual measurements trumps that because you know for sure what you're working with. And then again, we can jump up into this loft space and get an angle off these timbers and see what elevation, an angle we've got on our roof structure as well. And to do that, I'm going to use the Climb Tools angle gauge. I'll jump up there now and show you how we go about doing that. Okay, so you can see I've jumped up into the little loft space. I've got my Klein angle gauge. If we pop that on to the timber, see that again, that's against the roof structure of about 35 degrees, which is what I was sort of expecting looking at it. We will just check the other pitch to ensure it is the same. And again, about 35 degrees. These are fantastic. I've showed them before. Bending conduit where you can use it to set angles. It'll also do like a worktop, I guess, if you fit in to get that flat. There's loads of features built into this. It's really handy on your solar PV surveys. So you can get a pitch of roof very, very easily. No need to get your steps out and go on top of it. Jump in the loft and use one of these. So another important aspect is the customer's actual consumption. You want to know what their energy use is to propose the best return on their investment from a solar PV system with some planning for the future. Obviously, moving towards electric vehicles, they may have an increase in consumption due to that or other factors. So it's worth having those conversations with your clients and see how they want to pitch their system. And in this case, there's a couple of people live in this place. They do work from home, but the consumption overall is relatively small. So we're looking towards a 5 kilowatt inverter with an east-west split on this garage. True south, if I can figure out how to spin you around on here, I can't, so I'll just have to stop the recording. True south is exactly that way. So this roof is split east-west in full. So we can have quite a prolonged period of generation. As the sun comes up in the east, sets in the west, it's going to be kicking out something all day. So you may want to look at the battery bank sizing to cover them off for their evening use, and also see about the amount of power that they're using through the course of the day. And you can try and pitch that for the worst scenario in winter, but the size of your arrays get ever bigger and the cost of that ever higher. And then conversely, in summer, there can be a lot of export. You need bigger bigger inverters to accommodate that. So it's finding the fine balance to match customers' wants with their budget, and also, you know, what's going to actually work best through all seasons in the UK. You also need to look at the condition of the roof. So you can see this roof is in pretty good order. It's concrete tiled, pan tiled, so you need to make sure you're taking note of that. And then also the size of the roof that you're intending to mount your panels, and gauging if you're going to do it landscape, portrait, and how many you can fit up there. Fortunately, this is a very generous roof space compared to the generating system we intend on putting in place, so we should be fine, but we can run through that in the design software later on. So there is another important aspect if you're intending to use existing circuitry and also potentially existing switchgear and consumer units, that you need to have a look at it and take some test measurements as well. I always would advise that. And in this case, I'm just going to use a local socket. I'm not going to go to the trouble of putting terminals on probes and such. Got a little length of cable in here. It's going to add a bit of impedance, but it's negligible. So if we go into our loop impedance, you can see it's giving us a value of voltage, which is around 230 volts-ish, near enough. If we hit test, it'll give us our values of ZS down here, or ZdB, near enough, and also the loop for line and neutral as well. And I've set the no trip to 10 milliamp because there are RCD stacked on this install, and I don't want to upset anything inside the house. You can see we've got an LN loop of 0.63 and an LPE of 1.1. And again, this is currently sat on a 20 amp circuit in the house. I know there is a ring main down here. I don't know quite why it's been set up like that. It's just how it is. So yeah, we've got that to factor in. Now, the beauty of the MFT Pro is it's more than just your average test instrument. So you can see there's a volt drop option here. Now, I've been off earlier and calibrated it with this button here. I'll pop a little screen grab of that alongside this footage now so you can see it. But I've gone off to a local socket to the consumer unit, press that button essentially, and it takes a value of ZS, I assume, or Z as it calls it, be the live neutral loop, sorry, the impedance value there, stores it, and then when we come down here and hit test, you can see it will give us a yay or nay in terms of volt drop. So you can see I've set a 20 amp circuit because we've got a 5 kilowatt inverter that we're proposing. We've got our 3% max. There's the 1% issue for solar PV, so we've got that aspect to cover in as well. And you can see it's coming out at 2.5%. It's the information at this stage that is vital. We can make a decision on what we're going to propose once we've recorded all that. So you don't need to say yes or no. If you're unsure and you want to go off and pop it in the design software, we can use ElectricalOM and see how all that plays out. But gathering this data using a simple test instrument, and also we can form some calculations based on the ZE of the install and also the ZS we're getting down here. It's actually a TNS system. However, we're to assume those are all TNCS now, as we realise. So yeah, we can use all of the normal maths we would do and factor in this as well. It's just a useful tool to have in your test set to be able to do very quickly and give you a good idea if you've got an issue with fault drop before you're adding in any additions or alterations, especially when you're a good distance away from the main supply. And we do also have the big run back to the house. The consumer unit is tucked down that side. It is a good old run, so we'll get the measuring stick out and give it a measure for the best route. There is a soft dig down the drive where we've got the option to maybe go across and do bits and pieces. So we do have those things in our armoury, and while we're here doing our survey, it's better to get all that information in case you need it later on and we're not able to use this existing cable down here or what we're intending to do with solar. You can see someone else has popped some on that garage roof over there as well, so there is already existing solar. Obviously we've got our G99 to consider, and that's one of the things to remember when you're doing a survey. You are considering your proposal, what you're intending to recommend to the customer and put forward in a quotation. But also in the back of your mind, the G99 stuff, have a look around in the local area, see if the neighbours have already got solar. That can be both a good and a bad thing. And you can gauge what kind of system you expect, so you may be able to get away with on your G99 without upsetting the DNO too much. You're also going to need your customer's MPAN, so you can ask them for that, get it off their electricity bills. If you're already registered with MCS, you can use the MCS database to get that data as well. So yeah, sorry, just to mention, if you use the MCS database, you can pop a certificate in as if you were doing one, and when you get through it so far, it will give you the MPAN of the customer. So if you do forget to get that during the survey and quote stage and you don't have to ask them for it, it is in there and it should be accurate. So that can help you out with your G99 notifications. Just a little tip there, if that helps anyone out. And then you just want your proposed locations of where you're going to put stuff. Let the customer know that they may have to move some existing things to fit bits and pieces where you want them. So if we're going to fit our inverter and stuff, it makes sense to pop it on this wall. To be fair, all the walls are full of stuff, so it's going to have to go somewhere. But that's on a breeze block wall. It's nice and straight and true, and there will be plenty of space if they just get rid of one of these units to somewhere else to give us a bit of space to work with. It's near all the existing wiring. Makes sense to pop it in that space to me. And yeah, that gives you a good idea of what your layout is going to be from there in terms of your batteries and your inverters as well. Okay, so with Room Scan on ServiceMate, you can actually use your phone to scan the room, as you can see me doing here. So we need to make sure we pick up all the corners, get ourselves right in there. So he's doing that, and it'll pick out features of the room as well. It remembers where it's been. It's using AI and all that clever stuff. So just make sure you get a good scan of the room. You can see it's picking out these units. It knows there's something there on the wall. Get right into the corners. It should see that there's a garage door both here and here. See what it's doing. Give it a good overview of it. It should pick everything up once you've scanned everywhere. You can see the room forming in the bottom below there. And the more time you spend walking around and scanning everything in, obviously this room is quite full of stuff, the better estimate you'll get in terms of size and layout. If we press done, you can see we can now see inside our little room here. So it's picked out bits of furniture that's knocking around, and obviously the double garage doors. And if we go and look at the actual room scan, it will give you a floor area assessment as well. So you can see we've got 39 square meters as a guess using the software, and I know from using the actual measure I think it's about 38 point something, so it's pretty close. Okay, so we can use maths from the footprint of this building to give ourselves a measurement on the roof size. However, we can use our laser level again, and if we pop it in the ridge, so this is right at the top of the roof, and then we shine it down into the bottom of the roof, which is down the other end of here, and you can see I'm getting 3.3-ish meters, which is pretty accurate based on those maths as well. Okay, that's just using the laser level. You can see the little red dot on the felt there, but again, just shine it down the pitch. You'll see on this side, get it up against the roof, aim it down to the bottom. You can see the red dot on there, and then look at your measurement, and we can see if it's focusing. I can't see because you're too close to my eyeballs. It's 3.3, 3.4, which is good to know. So now we've got all that data, and we have looked at the roof space, we've looked at the condition of the timbers and size of them. You need to measure those as well. And we've spoke to the customer, got their consumption, got their MPAN. We've seen what cable size we've got down here already. We've taken measurements of ZE at the install, ZDB down here. We've also used the TIS MFT Pro to give us an estimation on bolt drop through the sockets. Obviously the extra little bits of cable I was talking about within those measurements, but it's pretty close. And we can use all of that to then propose a system and work with some of the design software, as we'll have a look at now, back at the office, and see what we come up with. So I thought I'd very quickly show you the design software. So this is Easy PV, and I've put an overlay on the building, and you'll see that doesn't quite match it with where the ridge is, and this is the drawback to some of these aerial surveys. If you're not square over the roof, some of the elevations can look bigger than others, so it's worthwhile getting yourself to site and measuring to be absolutely sure. I've put the external measurements of the building into here, so obviously with some of those internal measurements I was showing you, it doesn't take account of cavities, the exterior and interior skins, and any overhangs to eaves and such. So it's important you get the actual measurements and pop those in. Now with Easy PV, when you've done that, so you can see I've got the degrees here as well. So we've got that 35 degrees. We've got the height to the eaves and then to the pitch, and that's all taken account now in the software. If we click next, you can see it's given us an approximate space of 12 to 18 panels on each side. However, as we know, we want sort of around 5 kilowatts on each side of the roof. You can see here, if we position them in landscape, we can get 12 panels on. I've specified 435 watt Jinkos, which gives us, roughly speaking, 5 kilowatts of output per roof. So we've got the west and the east, and they mirror each other in full. Now you can see here, if you want to start selecting your bed blocker, different types of rail system, Easy PV is limited to these very few options. We use Van der Valk, so you can use the Vault Planner as well to set your roof out, and then you know how many hooks and what rails and clamps and everything you need. This is just an easy way to pop together all of the components in terms of performance and such. So if we move along and look at the inverter, you've got loads of different options for what you would like to choose. You see I popped optimizers on here, so we're just using Tigers, Tigers, and then we've gone for 12 panel strings, obviously the east and west. Optimizing really because there is a little bit of shading off the neighbour's tree on one side. The other side doesn't especially seem to have any issues with shading. However, for the safety benefits that come with optimizers, I still think they're worth including. So we've popped those on this system. You can see here as well, we've gone for the Give Energy all-in-one AC coupled battery system, and that's going to live in the house near the consumer unit, separate to the PV. So the PV is going to feed back into the gateway. The actual inverter that we've looked at on this one, if I can find it, is the Solax 7.5 kilowatt hour inverter. Now, obviously, we're only running at just over 5 kilowatts from each string. However, there will be some crossover in generation between the two, so a bit of overpower may be present at times. So it's well worthwhile popping a larger inverter on if the DNO will let you get away with it, because they will often just go off the rating of the inverter, not the actual output power of your array. So something to keep in the back of your mind. And again, with this one, we're not specifying any of the batteries of the hybrid variety, because you can have those things working against each other when you've got an AC coupled battery and DC coupled batteries. Won't get into all of that right now. The reason I've gone for the hybrid is so that the garage power that's down there already, if we are going to use that existing cable, and I'm still not sure that we are, to be truthful, we can use the EPS port on the hybrid inverter to power the garage lighting and sockets, and it will work in that way without needing to run a separate cable down there. And like I said, the consumption due to the stuff that's in the garage is negligible. It is just lighting and CCTV and such. There's really not a lot going on down there. But we do have to factor that in, and otherwise we're putting in a consumer unit in, taking separate circuits off for the PV system and also the garage system, and this is just an easier way of doing it, I think. Let me know what you think in the comments, if you would do it like that or not. But you can see anyway, regardless of that, this isn't necessarily the proposal we're going to put to the customer. It's just something I've quickly popped together for this video. But you can see we've got a max current on the inverter of 14 amps, which we are within for these particular panels. So we've got lots of ticks for our optimizers and panels, which shows we are in good order. You can then go on and set what phase stuff's on if it thinks it's a three-phase system and such. If you specify an AC coupled and DC coupled inverters, it will always give you that option in this particular software. You can spec your cable sizes and any types of DC isolators that you're wanting to use. You can see I've popped 6 mils and 10 meters here, just a best guess based on where we're anticipating to run our cables. If we want to run any meters or anything like that, they're all in there. And, in this case, we've got the meters in the gateway, so we don't really need any additional meter, in my opinion, on that one. We are going to pop an eddy on this, so there is going to be an eddy. If you noticed in some of the clips alongside this chat, there was a shot of the tank and stuff that's very close to the consumer unit, all of that stuff. So we're going to try and make best use of any excess generation to potentially use the immersion element on that as well. Might have to blank some of this off, but if we have a look at the electrical side, no, we've done that, sorry. If we have a look at performance, so if I go back, you can see here I popped a bit of shading on, and really it is for the trees and stuff next door. There's a bit of horizon shading as well. You can calculate that using the software here, but it'll just pop in a shading factor so you're not running at full lick off your strings. If you see here, we've got string 1 and string 2. They're basically outputting the same power because of the panels, but 1 is an orientation from south of 79 degrees, 101, and the inclination at 35, postcode region, and then it gives you all of this magic. So you can see the string 1 is anticipated to generate a little bit better than string 2, but there's not a lot in it, and overall, pretty good output based on the customer's consumption. So if we jump back to the overview again, and then we can go to the consumption. This is where it gets a little bit tricky because I have specified an all-in-one alongside the Solax battery system when really there's only one going in. It doesn't like it, so it will start to mess about. But you can see the annual consumption is around 5 kilowatts, and the solar generation is 6-7 kilowatts. So as you look at the chart here, this is where things get a little bit complicated, but it takes a sample day and shows you your array annual generation. So the solar PV array is expected to do 6-7 kilowatts. The graph shows whether the generator energy is used directly in the house, used to charge the batteries, etc. 28% of the electricity generated is expected to be used directly in the property. 30% is directed to the battery. 266 kilowatt hours of this is lost during battery charging and discharging, leaving 1700-ish kilowatt hours for use in the property. The remaining generation is exported to the grid, and you can see that here. And that's typically happening in the peak of summer when the battery's going to be full, the consumption isn't high enough, and that is just going to be sent off for the energy company to pay for, hopefully. And then conversely, in the winter, when we get further along at this, there'll be times where you're importing from the grid. You can look at that here. So you've got your import period, which, as you would expect, in the sunny UK is generally speaking December, January, and then it starts to drop off as we head towards the end of March, and then be reintroduced again in October. It's got what you'd expect. The battery utilization, so you can see here, average battery utilization of 37% annually, and then when it's in a specific day, obviously it varies based on sunlight and what the user's consumption is. There's no set hard and fast rule to this. It's just a best guess that software is making. If we have a look in now at the schematic, you can see it gives us a rough drawing. So the all-in-one and gateways stuff is going to be near the consumer unit in the house. We've got the solar PV system down in the garage with our panels running into it. And again, I'll have to blank off the customer's name and address. We won't run into the financials because they're different for everybody. You can see here you can generate a PDF, send to your customer, basically outlines all the equipment you specify. And this is why I was saying it's a bit of a mix up with the all-in-one, because I have specified it on the same inverter as the Solax and then put it as an additional generating unit. It's just weird how this software works with the all-in-one. I'm sure there's probably a better way to use it than I am, to be honest. And then you can see here there's the roof inclinations and also the sun path diagrams we're expecting to generate. And then you can see again the annual generation. It sets it out for the customer in a way that they can hopefully understand and explains a bit about all the eco green stuff that this stuff allows us to do. And there's the quotation side of things as well. But again, I'm not running through the financials of what we do in my business. It is different for everyone. I did also want to look at Modexsoft ElectricalOM, and that is more looking at electrical compliance. So we're looking at the design of our circuits, and as I showed when we were doing the survey, there is a bit of an unknown on that cable coming down to the garage based upon the percentage of volt drop that we are going to accept in our system. And we try and work with 1% with solar PV. There are some caveats to that. We've covered it on the Apprentice 1-to-1 design series. I'm not going to delve into all of that at present. Hit the regs up, look at your PV design, COP, and there's information in there about all of that. However, if we look at the schematic on this, if I zoom you out a little bit, and then we'll just journey up the screen, and we can see what we've got. So we've got our supply into the installation as a TNS. I've got our ZE that we measured and set. We've got the fuse, which is an 80 amp supply in the head, the meter, the tails, to our distribution board. And I've just popped a couple of circuits in real quick as a bit of an example. We've got the cooker circuit in there, and then we've got the circuit we're going to pinch from the garage and use for our solar PV. So we'll focus in on that one. You see the solar PV there, and we get the AC side and the DC side of it, and they're highlighted over here. You can see the solar PV inverters actually in red and giving us an error. I'll speak about that in a second. But if we go to the DC side of things first, so we'll have a little look at string one. So you can see you can insert the details of your panels, and as we said, these are 430 watt Jinkos. I've popped all the ISC, VOC, IMP, VMP into here already. And it's given us a value of volt drop on the DC side and explained what the maximum length is based on our overall volt drop that we want for this system. We've specified the 6mm cables, the estimated length of them, all the same as what was in Easy PV. And it's the same on the west array. And obviously these are east-west splits. Now when we're going to the solar PV inverter, it's giving us a warning error on the DC to AC ratio because, as it states in here, industry standard is 1.2 different in your sizing. Anything above 1.5 is not recommended. But because our array is split east to west, that could do with an option. There may be one in here that I've missed already, in fairness, and this is new for Electrical OM, so they're developing and building on this all the time. It's probably something that is going to come if it isn't in here already, and I missed a button somewhere. But we haven't got 11, 12 kilowatts of DC generation all at once. It's not going to happen because of the way the roof is set. The sun moves across the sky, and the generation falls and rises due to that. So that's just something there that's flagged up in the software. But you can see anyway the volt drop based on all of the measurements. I've put the circuit length in. I've put the overcurrent protective devices in. So I've gone for a 25 amp rated RCBO for when we take over this circuit and pop it down there. And the volt drop is coming in at 0.98%. So it's really, really close for if we wanting to do that based on design. So that's the measured length of the circuit, it's the size of the conductors, and the anticipated generation. There may be things we can do to make this work if we're going to propose doing it, but it's where you've got to be really careful. So obviously, if you put that forward as an option to your customer, go ahead and install it, and then it doesn't quite work and there's too much volt drop, you've then got to have the issue of running a very long cable through someone's garden down to a garage at your expense, most likely, to make things work correctly. So it's well worthwhile using this kind of software to double and triple check what you're doing before you propose it to a customer. And if we look at the volt drop again on the PV inverter, you can see the voltage rise inverter to grid, we've got 1%. So we're right on there. We're right on there. And again, the negligible load down at the garage isn't really going to cause us any issue or impact. If there was more stuff going on down there, I'd be more concerned about that. But yeah, it's one of those. The customer isn't over keen at having the garden dug up, so we can have a better look into that when I've got a bit more time. Just really setting this out raw as I've gone to do the survey and talking through it. I'll bat this around for a good while longer, but it would become a pretty boring YouTube video. But yeah, just to show you there what you can do with Modex Soft Electrical OM. There is a 2-week trial of this. I've showed it on the channel before. If you want to go and have a look at some more detailed videos where I build these systems up and talk through doing it, they are on there. I'm not going to do that on this one. It is just a brief look at the considerations we need to make when we are doing our proposals. And obviously all of this information would then feed into a G99 application if the customer proceeds with an order based on what we have suggested for them. And again, after that, you can then map against what is actually installed and the test measurements that you're obtaining against what the design is telling you should have, and it gives you an overall view of compliance and assurance. I will just very quickly bring up the Jinko datasheet on the panel, so you can see again where we've got this information from to enter into Modex Soft. It's all on there. So that's your standard test conditions. They are the knocked values as well for if you need to insert them at testing stage. There's sometimes in the PV check, for example, you need this data too. So it's all on there on the data sheets. Hope that's useful. Let's move on with the video. I've been taking a look through this one with me. How would you approach it in terms of your proposal? What would be the kind of system you would be looking at putting forward on this one? And what do you think regarding the volt drop down to this garage? Any comments you've got in and around all of that, please do drop them in below, and you can come back in a few weeks' time and see how this installation progresses when the proposal has been accepted and we have our G99 in place, ready to go. But it'd be interesting to see what the audience and those of you following along on YouTube think of this, and share some of your ideas and views. I will show mine later on the channel. And thank you very much to everyone who has been watching, liking and subscribing so far. If you've not done so already, it would be massively appreciated. And otherwise, I will see you on the next one.